For most developers, working with AI assistants involves guessing. You spend hours tweaking text prompts, hoping it finally spits out the code you need. That guessing game ends with a GitHub repository called antigravity-awesome-skills. Instead of typing out instructions from scratch every time you open your terminal, you install a searchable library of over 1,441 pre-written, highly specialized playbooks. You stop coaxing a chatbot with open-ended requests and start handing it strict, executable operating procedures. Standardizing how the AI receives its instructions builds a disciplined engineering workforce within the terminal. Deploying this system takes exactly one line in your terminal, bypassing the old workflow of scouring the web, copying the text, and pasting into a chat window. Within seconds, your local environment populates with professional workflows for security audits, UI design, or test-driven development. Living directly inside your project, the AI treats these files as strict standard operating procedures, following the constraints exactly as written. Deploying prompts as strict, localized SOPs provides the consistency required to manage automated operations at scale. The engine driving this reliability is the CLI installer itself. It routes these playbooks deep into the hidden folders of whatever coding environment you prefer, whether that's Claude Code, Cursor, or Antigravity. The skills are stored as lightweight markdown files, skipping heavy dependencies. By building a boundary directly inside the file system, the AI gets immediate access to local context while remaining physically bound by the playbook's rules, which standalone chats can't enforce. Because it reads those rules right next to your codebase, the AI can align its output with your project's specific constraints much more consistently. Bridging the gap between human intent and autonomous execution requires this exact type of localized infrastructure. Of course, building a full application requires more than a single skill. You need different agents handling different parts of the project. This brings us to a less obvious but vital feature of the repository: sub-agent delegation. Tools like Guardian agent prompts act as project managers, organizing tasks and assigning work to specialized AI models. They enforce strict anti-duplication logic, ensuring that when agents hand off tasks, they never repeat work or overwrite each other's code. Adding managerial oversight transforms a simple collection of text files into an active operational control plane. But a system this large has physical boundaries, specifically regarding context limit overhead. Forcing an AI to process 1,441 skills simultaneously quickly burns through token limits, overwhelming the context window. To prevent a total collapse, the repository includes auto-recovery skills, built-in fail-safes designed to catch the AI before it crashes. The documentation provides two specific protocols: agent overload recovery for handling bloated memory, and Windows truncation recovery for fixing sudden interruptions. A mature workflow system proves its value not just by how fast it scales, but by how cleanly it manages its own breaking points. Modern software development treats the AI as an execution engine. The old habit of saving scattered text prompts in a web browser is giving way to locally installed, highly structured playbooks. In this system, the developer's role transitions from writing the code to managing the digital workforce that produces it.